Hi everyone, welcome to a new edition of Discovering a Scientist Live. Today our guest is Enrico Fermi, who is considered one of the chief architects of the nuclear age. He's known to have done great discoveries on the atomic nucleus and radioactivity, but he had done many more which he will talk about us now. And actually, he participated in the Manhattan Project. That means the atomic bomb. So, hi Mr. Fermi. Such a pleasure for us having you with us today. How are you?
Hi Jonathan, hi everyone. I am very excited for being here to talk about the incredible things of our world, and to inspire the youth explore their environments. You don't know what you can find.
Great, Mr. Fermi. So please tell us more about your life. What about your early years?
Well, I was born in Rome, Italy, on September 29, 1901. Since I was a kid, I have had attitude for mathematics and physics. In 1918, I won a fellowship on the Scuola Normale Superiore of Pisa. I spent 4 years on the University of Pisa, gaining my doctor's degree in physics in 1922 with Professor Puccianti. Soon afterwards, in 1923, I was awarded a scholarship from the Italian government and spent some months with Professor Max Born in Göttingen.
Great, Mr. Fermi. So, what about your discoveries? We know that you've done many great discoveries, so please talk about that.
Yes, Jonathan. Well, in 1926, I discovered the statistical laws, nowadays known as the Fermi statistics, governing the particle subject to Pauli's exclusion principle. And in 1927, I was elected professor of theoretical physics at the University of Rome. During the early years of my career in Rome, I studied electrodynamic problems with theoretical investigation on various spectroscopic phenomena. But then I focused on studying the outer electrons towards the atom's nucleus itself. And then in 1934, I developed the beta decay theory, coalescing previous work on radiation theory with Pauli's idea of the neutrino. And following the discovery by Curie and Joliot of artificial radioactivity, I was able to demonstrate that nuclear transformation occurs in almost every element subject to neutron bombardment. And this work resulted in the discovery of slow neutrons, leading later to the discovery of nuclear fission and the production of elements lying beyond what was until then the periodic table.
And what about your personal life? Are you married? Do you have children?
In 1928, I married Laura Capon. We had 2 children, Giulio and Nella. And for you to know more about myself, my favorite pastimes are walking, mountaineering, and winter sports.
Wow, I didn't expect that you would like winter sports. But anyway, so you are Italian, but you moved to the United States running away from Mussolini's fascist state. And also, when you moved to the US, you were awarded with the Nobel Prize for Physics. Talk us about this.
Yes, in fact, I arrived to the United States on 1938, and I was appointed professor of physics at Columbia University in New York. In the same year, I was awarded with the Nobel Prize in Physics. I was awarded this prize because of my demonstrations of the existence of new radioactive elements produced by neutron irradiation, and for other related discoveries of nuclear reactions brought about by slow neutrons.
Okay, so we know that you have done many more scientific investigations. So please tell us more about it. What about your participation in the Manhattan Project?
One of my featured experiments was upon the discovery of fission by Hahn and Strassmann early in 1939. I directed a classical series of experiments which ultimately led to the atomic pile and the first controlled nuclear chain reaction. Also, I played an important part in solving the problems connected with the development of the first atomic bomb. So I was one of the leaders of the team of physicists on the Manhattan Project.
Mr. Fermi, now you are American citizen, right? What you have done now that you are an American citizen?
Yes, in 1944 I became an American citizen and I was given a professorship at the Institute for Nuclear Studies of the University of Chicago. There I turned my attention to high energy physics and led my investigation into the pion-nucleon interaction.
And what about your studies on electromagnetism?
I studied electromagnetism in my last years, when I occupied myself with the problem of the mysterious origin of cosmic rays. And I developed a theory according to which a universal magnetic field, acting as a giant accelerator, would account for the fantastic energies present in the cosmic ray particles.
You have done a great job as a professor in different universities. Can you tell us some more experiences inspiring the youth through your lessons?
Yes, as a lecturer, I've been always in great demand. I gave several courses at the University of Michigan, Ann Arbor, and Stanford University in California. In fact, I was the first recipient of a special award of 50,000 grant for work on the atom.
Mr. Fermi, a last thing that you want to say to our audience?
Yes, I would like to say that when you perform an experiment, there are two possible outcomes. If the result confirms the hypothesis, then you've made a measurement. If the result is contrary to the hypothesis, then you've made a discovery. Thank you, Jonathan, for the interview, and thank you all your audience also. Bye!
Thank you so much, Mr. Fermi. I think you are one of the greatest scientists of the 20th century. You're definitely on the Olympus of the modern science, along with Einstein, Newton, etc. Thank you for sharing your experiences and discoveries with us, and thank you all that are watching this. See you in the next emission. Bye bye.